going to move on and look at some specific solids here. Start with the prism. Prism is a polyhedron consisting of two congruent polygons that we call bases, and they have what are called lateral parallelograms. Think of them as walls. If we consider the prism to be a room, the bases would be the floor and the ceiling, and the walls would all be parallelograms. And I have some examples sketched out here below. Here is the first example. This is what we would call a triangular prism. The two bases are the two equal triangles, and then this wall, so think of a triangular room, the floor and the ceiling are equal triangles. This wall, three walls, this wall is a parallelogram, this is a parallelogram, and this wall is a parallelogram. Usually they are rectangular, but not every prism is required to have a rectangle as a lateral face. So in general, they are parallelograms. Here's another prism. This one we're a little more used to. It looks like a box. Now, because these are all parallelograms, in this case, they are all parallelograms, which is the floor, which is the ceiling? How do we know that it's not tipped on its side? Well, we don't. So we just assume that is drawn as is. This is the floor, this is the ceiling, and then we have four walls: front, back, left wall, right wall. Finally, here's another type of prism. This would be a hexagonal prism. This one's been tipped over. So this is not its base. This four-sided figure is not its base. Here's how we know that. All the walls have to be parallelograms. This shape is not a parallelogram. So this cannot be lateral. If it is not lateral, it must be base. So this hexagonal prism has been tipped over. We do not call the base whatever polygon it's resting on. Just because this is on the bottom does not mean it's the base. The base is two congruent polygons. All the lateral faces, all the walls are parallelograms. So this has to be the base, and this has to be the base. So if we were to draw this more correctly, we would draw this with the floor and the ceiling being hexagons, and we would have 6 walls that are all parallelograms. Those are prisms. There is really no limit to what the base of a prism can be. It could be a 74,000 sided figure. As long as there is an equal 74,000 sided figure directly opposite it, it's a prism. Also going to look at cylinders. Think of a cylinder as prism-like, but it's not a prism because this is not a polygon. If we were to unwrap a cylinder, it would look rectangular. And more on that in a little while. We have 2 bases that are circles, and then this lateral space here, think of it as like a wrapper on a can of soup, like a soup label. That is constant curvature. So we have 2 congruent circles, and then we have this curved space going around. And we'll look at cylinders a little more in depth shortly. Here's the big concept, one big concept of this unit, and that is surface area. Every solid has surface area. if you were going to paint the outside of a solid, the amount of area that you would be covering, the amount of space you would be painting, would be its surface area. Anything that would be covered on the outside. If you were to drop this solid in a big can of paint, if the can of paint was big enough that the whole solid would fit inside, wherever there was paint is the exterior surface. So if you have a solid that has craters or little dips or holes, paint would get there. That would be considered on the outside. For a polyhedron, the way you find the surface area is simply find the area of every single polygon and add them all up. Now, there are some other shortcuts we're going to look at, but those of you looking for one formula to solve every problem, you're going to be disappointed. There are some techniques you can use, but this is the one that works for every single time. Find each individual area, add them all up. If you have 75 faces, well, you've got 75 areas to add up. And we're going to take a look at how to find surface area of a prism, and then we'll look at surface area of a cylinder. Here's a prism. Here's our first problem. Surface area of a prism. Again, there is no one formula for a prism. It's case by case. And the reason for that is prisms will have different bases. This prism has a triangular base. If I change the base, I change the area formula, because we don't use a triangle formula to find the area of a rectangle. We don't use the triangle formula to find the area of a regular hexagon. We have to use area formulas appropriate to whatever polygons we have. So every prism will have its own unique formula. Now, we do know that the two bases are the same. So if you find the area of one base, you found the area of the other one, and we simply double it. If, in this case, we have 3 parallelograms, we have to find the area of each one separately. Well, prisms have what are called base area and lateral area. Base area, obviously the area of the bases. Lateral area is all the area in between, so all the area of the walls. Again, if we think of this as a room, lateral areas would be the walls. So each of these lateral faces, each of these parallelograms, would be lateral area. So let's start with the base. And because we're referring to the base as a shape, we call it capital B. And I'm abbreviating capital BA for base area. Little b refers to base as a length, like the base of a triangle, the base of a trapezoid, and so on, the base of a rectangle. Capital B means a base shape, a base polygon. So that's how we keep the two straight. So area of the base. Well, we have 2 triangles. Each triangle is 1/2 base times height. And notice I used the little b to represent the base. Looking at my triangle, I see the lengths 3, 4, 5. Now we know from prior units that this is a right triangle, because 3 squared plus 4 squared equals 5 squared. So we know we have that right triangle there. There's my base and my height, 3 by 4. So our base area comes out to be 12 square centimeters, not cubed. We're still finding area. We're not dealing with anything else. We're finding area. Area has square units. So there's the base area. Lateral area. Well, we have three parallelograms. We have this one, which measures 5 by 11. We have this bottom one, which measures 4 by 11. And we have this back one, which measures 3 by 11. So 4 times 11, add that to 3 by 11, add that to 5 by 11. Before we go further, you should probably notice that there's a factor of 11 in every term. Because a prism has equal height, no matter how you measure it, whether you measure it this way, or whether you measure it this way, or this way, or this way, the height of a prism is constant. And we're taking that height, that 11 centimeters, and multiplying it by every edge of the base. Makes sense. Because to calculate the area of one of the walls, you take the height of the wall, in this case it's 11, times how wide that wall is. And if you put all the walls together, if you measure the width of each wall, you get the perimeter of the room, the perimeter of the base. So another way we could do this is like so. Multiply 11 by the perimeter. There. So this comes out to be 11 times 12, which I believe is 132 square centimeters. There's our lateral area, the area of all the walls. Now we just have to put this together. The total surface area of this prism is the area of the bases plus all the lateral area. We know this is 12, this is 132. Our total surface area is 144 square centimeters. There's our total surface area. So, again, those of you that are looking for well, I want one formula that works for every single possible prism. I can't give you that formula because it doesn't exist. Here's the best we can do. 2 times, for base area, it's 2 times area of one base. For lateral area, it's the, I'm going to erase it, there we go. It is the base perimeter, multiplied by the prism height. In terms of a shortcut or a formula that always works for a prism, there you go. 2 times the area of one base. And then for lateral, find the base's perimeter, multiply that by the height of the prism, and then add these two results together to get the total surface area. There's your works every time formula. It's going to depend on what shape this is. That's going to affect how you find your base area, and then that is going to affect your base perimeter. Let's do another one. Here's a trapezoidal prism where we have trapezoid, here's another equal trapezoid, and then we have 4 walls. So we'll start with base area. 2 times the area of one trapezoid. Area of a trapezoid, half times height times the sum of the trapezoid's bases. So we know the height of the trapezoid is 2. One base is 4. One base is 10. Our base area is going to be 28 centimeters squared. Our lateral area. Let's use that shortcut from the last one. All of these 4 walls are 7 centimeters high. So we can take the perimeter of the trapezoid multiplied by 7. The perimeter of our trapezoid is, we have 3.6 and another 3.6, giving us 7.2. This distance is 10, giving us 17.2. Add 4 to that, we get 21.2. There's our lateral area. Or you could simply take 3.6 times 7, 4 times 7, 3.6 times 7 again, and for this back wall, take 10 times 7, and then add all 4 of those up. This way is a little quicker, and it looks like we get 148.4 square centimeters. I'm going to double check that on a calculator. Yes. Total surface area then is our base area plus our lateral area, 176.4 square centimeters. One final problem, and that is surface area of a cylinder. Well, here's a cylinder unrolled. Here's how we create a cylinder. We take a rectangle, roll it up, and we get a circle on each end, and then this is that rectangle that's been wrapped around. And this is sort of the reverse. If you were to cut this so that it unfolds, it would fold into a rectangle. Here's the net of the cylinder. In other words, if you were to cut this out, you could create your own cylinder based on it. Here's a circle with a radius. Here's the same exact circle on the bottom. And then here's that rectangle that wraps around. This is the height of the cylinder. And as this folds around here to create a circle, this length of the rectangle becomes the circumference of that circle. So that's where this 2 pi r comes in. So let's put this all together for surface area of a cylinder. Surface area of cylinder. We know the base area is 2 times the area of one circle. Area of a circle is pi r squared. and we have 2. We know the lateral area, the area between the bases, is a rectangle. And that rectangle has a length of 2 pi r, and it has a height h. I'm going to make one little switch on this picture here. I'm going to make that a capital H. Typically with solids, we use capital H to represent the height of the solid. Little h would be the height of an individual polygon. But since this represents the height of the entire cylinder, it deserves a capital letter. Put all this together, and the surface area of a cylinder is 2 pi r squared plus 2 pi r h. There is an alternative formula to this. Another formula that is acceptable is if you divide out 2 pi r from there, you are left with, in the first term, an r, and in the second term, the height. So if you take the radius plus the cylinder's height, multiply that by 2 pi r, you will get your surface area also. Either one of these formulas will work. So let's put a box around. So those of you that are looking for a formula that always works for the cylinder, now you're in luck. You can use either one of these. Let's take a look at a cylinder problem. And answer in terms of pi. So no approximation on this one. Let's use this formula. 2 pi r squared SA equals 2 pi r squared plus 2 pi r h. 2 pi, radius is 10 squared. 2 pi, radius is 10, height is 15. This first part calculates out to 200 pi. The second part calculates out to 300 pi. If you have 200 pi and you add 300 pi, you get 500 pi. Surface area of a cylinder. And just to show you that other formula, that it also works, I'll do that over here. This formula said we can add R and H together. R plus H is 25. 25 times 10 is 250. 250 times 2 is 500. Stick the pi on it, and we got the same answer as the other one, which we should. If we got two different answers, we'd have a problem. So there is the surface area of a cylinder.